Okay, we're going to do one more example problem for our 7.5 notes. In this one, we had a random sample of 2,000 each of U.S. men and women, both conducted in 2013. The Pew Foundation found that 23% of men and 21% of women believe that using embryonic stem cells is morally wrong and to use stem cell research. We're going to, in this case, let men be sample 1 and women be sample 2. First, we're going to check all of the conditions to make sure we can create this confidence interval, and then we're going to find a 95% confidence interval and use that to interpret, to see if there really is a true difference between these. Okay, so let's see. Let's check those conditions. 1, are they random? It says a random sample of, so it says each here, so we know each one of them are random. So check. Were they large enough samples? So large samples. Okay, so this is where we have to check, is N1, P1 greater than or equal to 10? Is N1 N1 minus P1 greater than or equal to 10? N2, P2, same thing. So these are the 4 conditions we have to check. Okay, so let's see, my sample 1, my N1, both samples were of size 2,000, so that's all of my N's. They were all size 2,000. The first one is min, so min is my 0.23. So I'm checking, is that greater than or equal to 10? And is the complement of that greater than or equal to 10? And then again, this one was another sample of size 2,000, but the percent here was 21%. Oops, I messed up. Sorry about that. I need to go, this one is the 0.79. I need to go back and erase. This one right here is not that. This one is this is 0.77. Sorry. I got ahead of myself. I was thinking ahead. So we need to check that all of those things are greater than or equal to 10, and we can check those, and they are all much, much greater than or equal to 10. They're all in the hundreds or the thousands. So those are all good. And are the populations big? Are they big enough? Okay, so what we would need in this one is we have to check is N1 That's what we're checking. So we definitely took samples of size 2,000 each. So we're checking is something more than 20,000 in each case. So what were the populations that these were being taken from? Well, it sounds to me like they were basically all U.S. men in one and all U.S. women in the other one. So this one would be U.S. men and this one is U.S. women. So are there more than 20,000 men in the U.S.? Yes. Are there more than 20,000 women? Yes. So that's fine. And then the last one is, are the samples themselves independent? Again, I would say yes on this, because one was all men and one was all women. So as long as those were truly random, they weren't husband-wife pairs or father-daughter pairs or anything like that. As long as they were really random, the men and the women should have nothing to do with each other. Okay, so all of our conditions check out. That means we want to go ahead and do our sample 1. We've got to do successes and observations. And then sample 2, successes and observations. So observations in both of them is 2,000. That's the easy part. How many successes? We're going to have to calculate that again, except we kind of already did. we're going to have to calculate what was the, I have to remind myself always, so min is sample 1. So how many men responded back that they believed this was morally wrong? Well, that was the 23%. So that was the 0.23 times 2,000. So that should be 460. And again, that's min. Just keep everything labeled here. So women was the 21% of 2,000, and that is 420. So those are the values we need to take and stick into StatCrunch. So I'm going to go back. I'm just going to close the one we had done last. Go back into my proportion stats, 2 samples, still with summary. This time I've got 460 out of 2,000 for 1, which is min. 420 out of 2,000 for 2, which is women. We're still doing 95% confidence level. Compute. Okay, so those are my values. Gonna flip over and record that. So the interval we get on this one is from approximately negative 0.0057 to 0.0457. That's the 95% confidence interval. Okay, and so anytime we're doing a 2 sample, when we're comparing 2 values, everything hinges on 0. So the question becomes, is 0 inside of this interval somewhere? And in this case, yes, 0 is in there. We crossed from a negative number to a positive number. That's what you're looking for. Do we go from negative to positive? If so, then 0 was in there somewhere. So for my interpretation, I would say something like, since the interval contains 0, we have to say something like, we can't rule out the possibility that these 2 population proportions are actually the same. So maybe the true percent of both men and women who feel this way, that stem cell research is morally wrong, who feel this way, is the same. So again, our samples came back fairly close, right? The samples were 23% and 21%, so not really that much different. And based on that, we can't rule out the idea that maybe truly overall, for all men and all women, they actually have the exact same percent, the same opinion about this. These are the most inconclusive type, though, because notice, because 0 is in there, we get this idea, the plausible of being the same. I'm not saying they absolutely are, just that it's possible that they are. Because note, there's also negative values. Negative values for P1 minus P2, if that comes out negative, then what that implies is that P1 is less than P2. So maybe it's less men than women. That's possible because there are some negative values in this interval. But then we've got positive values also. Positive values mean that P1 minus P2 was greater than 0, or that P1 was greater than P2. So maybe it's more men than women. We don't know. It's inconclusive when this happens. It could be any of the three cases. The one that we're usually the most interested in and that we talk about the most, and probably the things you're going to be responding most in MyLabs Plus, is the idea that it's possible, it's plausible that they're the same. But you have to keep in mind that technically this doesn't rule out any of the three options, because you've got negative, you've got positive, and you have 0 all being here